Hello everyone, welcome to Intelligent Transportation Society podcast. This is Dr. Anya Petrovskaya for IEEE ITSPodcast, and this is episode 39 for March 2017. I will continue to be with you in News Mini section. This is the News Mini section for episode 39, March 2017. Let's start with Tesla. NHTSA has released a report about a fatal crash involving Tesla, the one which happened on May 2016. Of course, the investigation has not found any defect in the system, but the good news is about the whole idea of auto steering. As a statistic shows, in this document, Tesla cars had 1.3 crashes per million miles traveled, which is reduced to 0.8 after installing the auto steering system, some 40% drop. Last week, UK introduced new self-driving insurance rules and measures to improve electric car charge points in vehicle technology and aviation bill. This way, the insurance companies have to cover the car both in manual and automated mode. Also, anyone injured by an autonomous car can claim against the owner's insurance and not file a private liability claim against the car maker. The authorities in the UK hope that this will make their country a platform to support and develop driverless cars. BMW, Intel and Mobileye will get together to release their self-driving car by the end of this year. They announced this news at CES 2017. Intel will contribute its computing power and Mobileye its advanced sensor technology. This BMW 7 series will be tested in the US and Europe. Have you heard about the lawsuit between Waymo and Uber? The case is mainly focusing on LiDAR technology. Waymo has received an email from a vendor which accidentally had sent this email and the scheme of LiDAR circuit was attached. Waymo claims that this circuit strongly resembles their technology. While Google and Uber are busy with their lawsuit, Indian government has invited driverless cars on its roads. And of course, the courageous company ready to do this is Tata Elxsi is ready to test drive its driverless cars on the roads of Bengaluru. Stay tuned, we will update you. To end this section, let me inform you about the workshop in IVY 2017. The title is Deep Learning for Vehicle Perception and Challenge on Efficient Convnets for Semantic Segmentation. The IVY community is invited to participate in a semantic segmentation challenge, offering a prize for the winner. The workshop program will include invited talks, presentations of the top 3 challenge winners, and a poster session of submitted works. You can opt for more information on their website. Thank you for staying with us. Professor Haluk Eren from Firat University in Turkey has prepared a review of a book recently published by Springer, The Advent of Unmanned Electric Vehicle, The Choices Between E-mobility and Immobility, written by Van Temsche. Let's listen to him.
This is the book review section for the present episode of ITSPodcast. Read by Dr. Haluk Eren, Firat University, Elazığ, Turkey. The book title is The Advent of Unmanned Electric Vehicles, The Choices Between E-mobility and Immobility, and consists of 392 pages. Written by Van Temsche, it was produced by Springer in 2016. This is not a scientific or a course textbook. It mentions about advances of e-mobility associated with safety of passengers, pollution-related diseases, better quality of life, global warming, and transportation costs. It also includes new business models, innovative financing solutions and technologies, infrastructure capacity against transportation demand. Demonstrating the challenges of transportation and e-mobility solutions facilitates to understand avoiding of immobility. The first chapter gives a framework and mega trends related to e-mobility technologies. It provides readers an overview for society-friendly e-mobility technologies. Also, it gives information about environmentally conscious and risk-averse society, mega and connected cities, new business models and transportation. Chapter 4 handles risk-averse society. It discusses safety concepts, including adoption of railway safety to cars, train control by communication, personal rapid transit, e-mobility technologies reducing fatalities, vehicle-to-vehicle communication, intelligent wayside technologies, driverless cars, and security. Chapter 3 focuses on environmentally conscious society. It consists of governmental initiatives, energy consumption, evolution of the electric vehicle market, greener technology, and some environmental issues. Chapter 4 discusses avoiding megacities' standstill. It gives information about private transport restriction, system and road capacity with manned and unmanned vehicles, carpooling, unmanned bus operation, transport mode capacity comparison, system costs and quality of ride. Chapter 5 elaborates connected cities. It mentions about the Internet of Things technologies, the mobile environment, M2M issues, predictive maintenance, and e-mobility technology limitations. Chapter 6 speculates for new transportation business models. It consists of financial issues, electrifying transport, private to public transport cross-subsidizing, internet connectivity, transport information supplier of choice, e-mobility software applications and business models. Last but not least, Chapter 7 concentrates on e-mobility likely winners and losers. In this domain, it discusses about the people ignoring the e-mobility revolution and adoption of e-mobility technology. Readers interested in next-generation e-mobility issues with unmanned electric vehicles will find useful information in this book.
Thank you, Haluk, for this wonderful review. It is March, and to celebrate the role of our women in this field of engineering, Professor Jeffrey Miller from USC has conducted an interview with one of our prominent researchers, Dr. Anya Petrovskaya. Let's sit back and listen to them.
Hello everyone, today we have Dr. Anya Petrovskaya as our guest. Dr. Petrovskaya has finished her graduate studies at Suffolk University and received her PhD from Stanford University and was awarded the second place best dissertation by the IEEE Intelligent Transportation Systems Society in 2012. Her research interests are in the areas of computer vision, artificial intelligence, and robotics. She mainly focuses on Bayesian methods for artificial perception in robotics and consumer applications. She's developed new efficient algorithms for autonomous vehicles, mobile manipulation, and tactile object localization. Dr. Petrovskaya is an entrepreneur as well. She's the co-founder of Ionite Perception, following the path of her research under her PhD. As they phrased it in their mission, it's to enable the machines to understand the real world. She was part of the team for the Autonomous Urban Driving Project at Stanford, where they built an autonomous vehicle called Junior. Her work was on tracking other vehicles on the road. In 2016, she was the co-author of the chapter of Active Manipulation of Perception in the second edition of the Handbook of Robotics. Also, in 2012, she co-authored Awareness of Road Scene Participants for Autonomous Driving in the Handbook of Intelligent Vehicles. Dr. Petrovskaya, I've summarized your background, but it would be really nice for our listeners to hear a little bit more from you.
Well, I think you've mostly covered it. I wanted to add how I got into AI and robotics in the first place. So this was in early 2000s when there were already more camera phones sold than actual cameras. And this was before the smartphone. And I realized that a camera and a phone is basically an eye with a brain. And the more that computers can understand our world, the more useful things they can do for us. Of course, although the computers can see the world, it is very difficult to make them understand it. And to work on this, I went to Stanford PhD program. So as a first step, I spoke to one very famous Stanford AI professor, whom I shall not name. And when I told him how excited I was about the future of AI and robotics, he told me, don't waste your time. We've been working on robotics for over 50 years. There are just not any real-world applications other than manufacturing. It's not going to happen. So I'm really glad that I did not take his advice because, of course, today there are many AI and robotics applications entering the real world.
Wow, that's really interesting. So in 2012, you were awarded the second place prize for your PhD dissertation towards dependable robotic perception. Can you give us an explanation about that?
Yes, I'm primarily interested in bringing robots into our lives in useful ways. And it turns out that the main obstacle to that is perception. In other words, the ability of robots to understand the world around them using their sensors. So I decided to focus on 3D perception to give robots spatial awareness as well as awareness of objects and people around them. As the first project I worked on was teaching a robot to perceive objects by sense of touch. Then I also worked on mobile manipulation, where robots can navigate our environments and open doors and pick up objects. And then later I was part of the Stanford's driving team, which built a self-driving car called Junior for the Urban Grand Challenge. And my job on that team was to teach Junior how to detect and track other vehicles on the road. Urban Challenge took place in 2007, and this was really amazing. We stood there and we watched how self-driving cars were navigating streets of a town, and they were following all the rules of the road, and they were courteous to other vehicles, both human-driven and autonomous. And this was the moment when we all realized that robotics has arrived. It really has become part of our world. So let me give you a little bit of insight into the challenge of perception. So to do perception, robots sense the world through their sensors like cameras, laser rangefinders, or tactile sensors. And these sensors have a lot of noise and also have a lot of ambiguities in the data. So to handle this uncertainty, we use Bayesian methods that can properly account for noise, ambiguities, and any unmodeled effects. So this involves estimation of probability distribution. In other words, a real valued function over a multidimensional space of parameters. And for the class of problems we have in robotics, it turns out that this function is really messy, where this messiness comes from properties of the real world and the sensors that we use to observe it. Because of this function is really difficult to estimate using conventional methods that we've just borrowed from other fields. In fact, at one of the robotics conferences, we had the keynote speaker who was a famous statistician. And I asked him what's the best way to estimate these functions, the type of functions that arise in robotics. His response was that our methods are capable of representing any function, but finding parameters to faithfully represent the functions that you have, well, we don't really know how to do that. So I decided to work on this to try to come up with algorithms that are better suited to the problems that we have. And I developed several, one of which I called scaling series. And with these algorithms, I was able to get several orders of magnitude improvement in both accuracy and reliability compared to the common methods, and across a number of robotics applications, tactile object localization, vehicle tracking, and so on.
Wow, that's amazing. So you had mentioned that you were involved with the Autonomous Urban Driving Challenge in 2007. Does it surprise you that we are just now in 2017 really starting to see more autonomous driving on the roads?
It does not surprise me. No, what we saw was basically the first time that robots entered into the towns and were able to do this. And it takes a while to go from that to the industry actually be able to produce these robots and make them available to the public. So no, it does not surprise me at all.
So you also are the founder of Anya Perception, which is a startup company based on your research. Is that right?
Yeah, that's right. So after the Urban Challenge, most of the team went on to Google to keep working on the self-driving cars. But I wanted to bring this technology to indoor applications, which is what took me to augmented reality and virtual reality. And I think that self-driving cars will have a tremendous impact on the world, but you will be primarily affected by it when you're traveling from A to B, whereas AR has the potential to be useful all of the time. So there is huge potential there.
And so how difficult was it to transition your research into a business?
We've had a software consulting practice with my husband for a number of years, even before I went to Stanford. And so afterwards, our research, our consulting simply shifted from what we were doing before towards AI and robotics. I graduated in 2011, which is when the first inexpensive depth sensors came out. And at that point, we were expecting that the problems of AR will be solved quickly. So in AR, you don't have a robot that perceives the world, but instead the device you have is a headset that the user wears. But it still needs to do the same things. It still needs to be aware of where it is in space. So in fact, the problem of stable head tracking is one of the biggest problems in AR, and it needs to be done with inexpensive hardware and also in a way that is easy for consumers to use. And in fact, recently Mark Zuckerberg called this challenge the holy grail of computer vision. So what we did was we applied the scaling series algorithm, and with that we can get much higher accuracy and stability, and doing that very efficiently. So we can use inexpensive hardware, and because it's inside-out tracking, which means the sensors are on the headset as opposed to placed in the environment. This makes it very easy for people to use. Simply you put on the headset and it just works. So once the depth sensors came out, we were expecting that this problem would be solved very quickly. But a year went by, then another, and it still wasn't solved. So that's when we decided to work on it ourselves. And it was really a ton of fun building this technology. We had to solve a lot of challenges along the way. But in the end, we had a real-time mapping and tracking technology with accuracy on the order of 100 micron. Depth sensors that we use have noise measured in centimeters. So many experts have a difficult time believing that you could even achieve such high accuracy until they experience this technology firsthand. So that's the technology part. Of course, to implement it in the industry, you also need the business part. And we knew that that part is challenging because we worked at a number of startups and we saw it firsthand how difficult it can be to build a business. So we were looking for a really experienced business person, but also someone who was a good personal fit. And in fact, my Stanford advisor, Osama Khatib, was the one who introduced us to U3. At the time, U3 had a startup building snow removal robots, and he needed help with perception, which is why Osama pointed him our way. So when we met with U3, we talked about perception challenges for his robots, and afterwards he wanted to know what we worked on. We showed him the demo, and after the demo he said, well, you should not be helping me, I should be helping you. And at that point he became part of the team, and so the company could take off.
That's a great transition there.
Dear listeners, either you are a researcher in intelligent transportation field or are just interested, don't hesitate to contact us. We are recruiting volunteers and your help will be highly appreciated. Contact us on our email at ITSPodcast@gmail.com.
What challenges have you faced during this change from academia to industry? And for anyone else who's looking to do something similar, do you have any advice for them?
So my story is a little unusual because I actually went back and forth between academia and industry several times. I enjoy being right on that edge. But I do remember the first time I was leaving academia for industry, I was quite anxious. I did not know what to expect. And it turned out that working in the industry is actually a lot easier. It's a team-based environment where everyone succeeds or fails together. So people are very supportive of each other and depend on one another. And actually, when I went back to academia, I missed that because in academia you can be part of a team, but it's not quite the same. Academia is a very individualistic environment where basically in every paper you write, you have to prove that your work is better than what came before it. Otherwise, your paper will not even be accepted.
Yeah, that's true. There's definitely a difference in the teamwork that happens at universities compared to industry. So what are your plans for your future research?
So we want E&I to become the go-to perception company. And the core technology that we have can enable many applications. So in fact, we spent several months trying to figure out which one to go after first, and we chose the inside-out tracking. But there are many more to come. SDK for robots and drones, medical robotics, flexible manufacturing, home remodeling and shopping, and various AR games and apps. Now, if you think about it, making an AR game is actually very different from what game developers are used to, because now the characters have to act in the real world and react to real world events. So in fact, it is much better to think of them as virtual robots that are simply acting in the world. Today, having robots properly interact with the real world is still an open research problem. However, we're well positioned to help the developers and provide them with the tools needed to make real-world aware AR applications. On the other hand, we're also developing our core technology. We started with spatial awareness, moving on to awareness of objects, and eventually full situational awareness.
So are you still involved with projects at Stanford? It seems like you're quite busy with your business now.
Yes. I have maintained ties with my research group at Stanford, where we've built an underwater robot called Ocean One. It is semi-autonomous, and it can descend to depths already has been tested at over 100 meters, and soon will be tested at over 1,000 meters. And so 100 meters is actually deeper than a human can go in scuba gear, and 1,000 meters is deeper than a human can go even in a special pressurized diving suit. This robot has already retrieved a number of artifacts that sank to the bottom of the sea hundreds of years ago and were just unreachable until now. And giving this robot highly accurate perception will enable it to build super high definition 3D models of the underwater world, which would be useful for marine biology, archaeology, and a number of other applications. The other thing we want to do is we want to combine what we're doing with ENITE, in other words, virtual reality with the haptics that we're doing in the research group. And we want to put those together to let the humans operating the robot feel like they're really there, acting in the robot's place.
Yeah, that touches many different fields with the research, especially in the underwater autonomous vehicles and the underwater submarine you were just discussing. So I think that I already know the answer to this question, but earlier you said that you were originally advised to stay away from artificial intelligence and robotics. Would you have a similar view advising new students coming into the research world?
Yeah, not at all. I think it's natural for young researchers to be sort of anxious about the future. I'd say the easiest thing is to sort of try before you buy, do a few internships and see what it feels like. But sort of don't let that scare you into sticking to experiences as similar to the university lab as possible. In other words, don't just do large industry research labs. There is really a wide range of teams out there for you to try out. You need to find the place that's right for you. And to me, nothing beats the excitement of a fast-paced startup. And of course, this is the time to do it. There is a smart robot revolution going on out there. So there are lots of opportunities for young researchers. So get out there and become part of the story, the robot meets world story.
Well, that's some great advice that you have there. Well, thank you, Dr. Petrovskaya, for talking with me today. This was fascinating, and I hope that all of the listeners found it as interesting as I did.
It has been my pleasure. Thank you, Jeff.
Thank you, Anya. Thank you, Jeffrey. We hope you have enjoyed. Don't forget to subscribe and share this episode. Any comments or suggestion is welcome. This podcast is sponsored by IEEE Intelligent Transportation Systems Society. This was Dr. Anya Petrovskaya from IEEE ITS Society. Have a nice spring.